Okay, in these videos, we're now going to start to talk about derivatives of composite functions. And so for that, we need a result known as the chain rule. Now, I really encourage you to check out in the notes uh, this kind of demonstration here on the chain rule. The idea being connected circles. And if you think of these circles here as gears that are turning around, so as one circle rotates, it's going to cause another to rotate. And that's kind of the support. So what I look at here is if I turn circle A one whole time, it goes through a distance of 10 pi. One whole turn on circle B would be a distance of 4 pi. One whole turn on circle C would be a distance of 18 pi. And so what we're computing down here is if I do a full turn about A, how much of a turn is that about circle B? And likewise for the other ones. And so we look at that relationship with circles, and we arrive at this result, that the rate of change of circle C relative to circle A is actually the rate of change of B with respect to A times the rate of C with respect to B. All right, and that result gives us our chain rule. That's kind of showing how it comes about. There's a lot more to the derivation or the development of it, but that idea, and I really encourage you to look over that to kind of help you understand the chain rule. And so what we're going to be doing now is looking at the chain rule. So here's this result again. The derivative of a composite function is the derivative of the outer function, f, with respect to the variable u, times the derivative of the inner function u with respect to x. Or another way of saying it, f prime of u times u prime of x, where f is the derivative of the outer function and u prime is the derivative of the inner function. So f prime is the derivative of the outer function, u prime is the derivative of the inner function. And hopefully this inner-outer, we talked a little bit about composite functions back in the early part of the course, the little review stuff. So hopefully inner and outer functions make sense. If not, as we do some examples, it's my hope that you'll pick up on those. So let's consider some problems of doing the derivative. So here we have a function here. F of x is the quantity 3x minus 5 to the sixth. Now, we could take 3x minus 5 times itself 6 times and multiply all that out and eventually simplify it, and then take the derivative of that big old massive thing to get the answer. And our answer would be correct, although it may not be marked correct by a lot of computers or even people sometimes. But it's going to be a huge mess. It's going to be a huge mess. So instead, we treat this as a composite function, recognizing that we have an inside function, a piece inside the quantity, 3x minus 5. And so we call that u. We call that u. And then if we replace that 3x minus 5 on the inside with u, then f, in terms of u, would just be u to the sixth, which is a much simpler function. And so we can talk about the derivative of u to the sixth, and we can talk about the derivative of 3x minus 5. And so we're going to use those two pieces to work out the derivative of the overall function f. So we begin putting out all the detail here. This example here, I'm going to overload the detail. F prime of x is the derivative of f with respect to u, df du, times the derivative of u with respect to x, du dx. What is f? F is u to the sixth. So that's going to be the derivative of u to the sixth with respect to u as the variable. And then times the derivative of u, 3x minus 5, with respect to the variable x. And this is a result known as the chain rule. It's how we do the derivative of a composite function. I'm writing a lot of detail out right now. As we move along, I'll write a little bit less detail out. And then a little further along, as you get a little more comfortable, I'll start to leave some of the detail out, because it does, some of our problems do get kind of long. If we they're long enough as it is, and if we write extra detail in, then they get even longer. So here we go. What's the derivative of u to the sixth with respect to u? Well, that's a power. So we just use our power rule. Say, well, that's going to be 6u to the fifth. And then 3x minus 5, that's pretty simple. That's just a little linear expression. In terms of x, we can differentiate that real easily and get 3. Then we can put it together. 3 and 6 is 18. Now, the answer is not 18u to the fifth because our original function was in terms of x, and we want the derivative now in terms of x. We want the derivative now in terms of x. So we go back and say, hey, u is 3x minus 5. So we put that into our equation. 18 times 3x minus 5, all now raised to the fifth power. And now we have done our first derivative using the chain rule.